One common overlooked problem with cut quality, or if you're suffering from bad cut quality, most of the time it is a machine or plasma or setting relationship, but many times, and very often it's overlooked, it's drawing quality, the actual quality of your drawing. This video I just want to touch on some basics as far as good rules of thumb and good drawing technique. This drawing here that we have used in the other videos as a simple test drawing is actually a pretty good drawing because it's made up of lines and arcs, or in this case a circle, which is 2 arcs. Many drawings you get, especially downloaded from the internet, are made up of nodes, tiny lines. The machine will cut them, and many times they'll cut them just fine, and especially when most of those that you're downloading are for art, where it sounds like a sales pitch, but honestly a lot of the art stuff you like it to be a rough edge. You don't want to cut a tree out and it looks like a perfect symmetrical tree, because that's not what trees really look like. So sometimes it actually works to your advantage that they're drawn that way, but when you're trying to make structural parts, or parts that have to fit together nice so that you can weld them, it actually is better the less stuff you have. Less stuff, what I mean by that is, it should be made up of lines and arcs. One long line, or a nice swooping arc, instead of an arc that's made up of 900 little tiny segments. To give you an example, if you wanted to draw a top to this, you could do it several ways, an arced top. The easiest is just draw an arc and give it 3 points. And you could snap there and go to the center and snap, and then there, and then snap to the end. And that gives you a nice arc. And if you click on this, you'll see that it is one entity. It is one node. From this point, curving all the way up down to here, is to the computer one piece of information. It's one object. Whereas a lot of drawings will be made up of tiny little lines, and they'll resemble an arc, and for the naked eye they will be an arc, but when you zoom in, they're tiny little lines. Again, the machine will cut, and it'll cut it quite well, all things considered, but basically what happens with that is it is a gazillion lines of code to get from there to there, and the machine has to read each one of those, and it ramps the motors up and down accordingly on each one of those nodes. This will be one line of code to cut this whole arc out. If you were to draw it in line segments, this might be 200 line segments, which is basically would be 200 lines of code. So obviously it's not as efficient either. The other thing with drawings is to make sure that your objects are connected. Take this for example. I'm going to move this and purposely move this. Oops. Away from there. Okay. So it is not connected. What'll happen is it'll pierce and it will cut, but it's going to leave that. It doesn't know that you meant to connect that. So all your paths should be closed, unless of course you're just cutting a slot and you don't, obviously then you don't want them closed. But basically all your paths should be closed. Otherwise you're going to get a lot of pierce points. If another line was drawn in between here and it wasn't touching on either end, it's going to pierce there, and there, and it's just going to be a mess. So drawing quality definitely plays a part in cutting efficiency and in cut quality. The other thing to go along with this video is what I wanted to do was I want to save this. I want to show you in SheetCam how it can be used, just some quick indicators that will indicate to you what your drawing quality is like. So I'm going to load this into SheetCam. Okay, I'm going to do a couple of things. First of all, purposely left that process on. I want to show you all the different errors that will indicate a problem. Okay, over here as you can see, normally this is black. Now as you can see, this one's highlighted red and this one's highlighted yellow. That indicates a problem. If you notice the red one, Red means it's not going to do anything. It just totally disregarded all of what you told it to do. And if you move the cursor over, it will tell you and it will explain why. And basically in this case, inside offset, I told it to do it on layer 0. This layer does not exist. No paths were generated. Well, obviously, if the layer doesn't exist, it can't cut that layer, but that gives you a really quick visual indication as to whether your G code is going to even be remotely, the machine is even going to remotely cut like the way you want it to. If you see code over here or lines that are red or yellow, you need to stop what you're doing, put the cursor over and figure out why. It may, and it isn't always a problem, it may, you know, do it anyway, but it's not going to do it exactly as you told it to, and you really should figure out why. So the red means I'm not cutting anything. I'm not going to do what you told me to do because I can't. I blatantly can't do it. So that obviously you need to find out. And 99% of the time it's because the layer doesn't exist. The next one, yellow, is basically saying I'm going to cut it, but I can't cut it the way you told me to. And the reason this is because open paths were not offset. As you can see, an open path is where there's a joint. So if we zoom in here, remember how we saved, there's an open path here. Well, I told it to offset the line. If it is an open path, bear in mind, it has no idea inside and outside of what. Because, you know, for us, we simply look at it and say inside the square. The computer looks at it and says, that's not really a square. It's 4 lines that are drawn. They might as well be, you know, 4 straight lines. It has no idea that that is supposed to connect there. So that just 2 brief things to bear in mind when you're doing your drawing. Close the gaps. This gives you a brief, you know, visual indicator as to whether the code is good. The great thing about SheetCam and Mach 3, SheetCam and AutoCAD that work together, is SheetCam does not grab the program. What I mean by that is we can still go back into AutoCAD and let's change this, let's fix it. Now I didn't change anything in SheetCam, I left it all incorrect. Now we see that there's a problem. Let's go into AutoCAD and let's fix our problem. So okay, we need to close that up, that fixes the one. The other one is the layer isn't found. I was trying to cut it, it's because it's on inside layer. We'll change that to 0 layer. We'll save it again. Override it, yes. Now we can go right into SheetCam. Recent drawings, test. Okay. And boom, see, our code is white. It actually is going to cut both of them. And I didn't have to double click on the processes. And I didn't have to set up new processes. The same thing with, let's say you're going to be cutting a lot of this particular thickness and style steel, the 14 gauge in our example here, and I'm making lots of different shapes. I can do one and cut it and just leave the code as long as I leave my layers the same. And I don't have to redo it. I just have to open it up and then click the P, post-process it, and we're ready to go. It's actually, when you get used to it, it's an extremely, extremely fast and efficient process. You could go from basically drawing the square with or a bolt hole pattern or a wheel spacer, for example. You know, you can literally draw that in less than 30 seconds once you get comfortable with CAD. You can bring it in here and generate the code in roughly 30 seconds to a minute. Once you bring it into the control program, move the machine, you know, it might take you a minute, minute and a half to set your settings there, and you're cutting. And in less than 3 minutes total, you've got a part in your hand. It is pretty amazing with just a little practice and a little patience that you can become very fast at this. So drawing quality definitely plays a role. And also bear in mind your visual indicators here. If they're lighting up a different color, they're trying to tell you something. The one other thing I forgot to mention in the other videos is starting points. For example, on this one, you can see that your starting point is off, you know, out here. So now we have to make sure our edge of the sheet goes all the way there. You click the S and then the layer that actual process is on, you can move your starting point, which is really handy if you're using scrap or if you're nesting things. You've got another piece that's shaped somewhat like this, and this is definitely going to be waste anyway. You can move your starting point to there. Same thing with the inside. You just need to make sure you click on that layer, and then you can move it anywhere around here. Typically inside doesn't matter as much because that is your scrap piece. But it's really handy to be able to move the outside one especially, so you can get right up to the edge of a sheet, or if there's a space in between the two that's definitely going to be waste, you can put your starting point there, or what have you. And just take your time doing drawings. Let Sheet Cam show you what it's going to do. Take the time to look at the actual lines and see that they're, what you want to be. There's our red line which we drew, the arrows indicating our direction of cut. Make sure these aren't lit up any different colors, and then go ahead and post it and cut it out.